So let's go over some of the features of R. The first one, which was important back in the old days, when people were still using S plus, but the syntax is very similar to S, which made it easy for S plus user to switch over. This feature isn't quite so relevant today, where most people generally go to R directly. The semantics are superficially similar to S, in that it looks like you are working in S, but in reality quite different. But we will talk about this feature in future lectures. One of the main benefit of R is that it runs on any standard computing platform or operating system, let it be Mac, Windows, Linux, or even PlayStation 3. And these are this R has got frequent releases. Annually there is a major release and quite often bug fixes. So basically this is a very active development group which is going behind developing R. The software of the course of R is actually quite lean. So if you look at its functionality, it's divided into modular packages. So you don't have to download and install a massive piece of software, whereas you can download a very small piece of functional code, kind of functions, and then add things on as you need them. So its graphics capability are very sophisticated and give the user a lot of control over how graphics are created, and in my opinion are better than most of the stat packages we have today. It might even be the best for the general purpose statistical package. It's very useful for interactive work, as I said before, but it contains this powerful programming language for developing new tools. So it eases the transition from user to a programmer, and fundamentally actually for a language like this is that it's very active and vibrant user community. So the mailing list of R help and R dev are very active. There are many posts per day, and there are also a series of Stack Overflow where questions can be answered. So the user community is one of the most interesting aspect of our language. It's where all the R packages come from, and it creates a lot of kind of interesting features. Of course, one of course one of the aspect is that R is it's free, both in the sense of free beer and the sense of speech. So what I mean by that is that it doesn't cost you any money. You can download the entire software. You can uh, you can also do changes. So I'm going to divert for a second to talk a little bit more about free software. So with free software there are four basic principles. You have four basic freedoms. The freedom zero is the freedom to run the program for any purpose. So you don't need any permission from anyone. There is no restriction on how you can run the program, or when you can run the program, or what you can do, what you can't do with it. Then freedom 1. Freedom 1 is the study to is to study how the program works and adapts to your needs. So this happens almost every day, which is that you can look into the source code of R itself, so you can make changes to it if you want. You can improve the versions of R for your local copy. You can sell changes to it if you want. You can modify the program. You can any way you want to adapt to your needs, of course. So you can look at the source code for this to get freedom 1. Freedom 2 is that you have the freedom to redistribute copies, so you can help your neighbor. And so the idea is that you can give copies to others and you can sell your copies. You can do whatever you want to do. Lastly, you have the freedom to improve the program and release your improvements to the public, so the whole community benefits out of it. So this is freedom 3. The idea is that when people make changes to the program, they can release them to public so that everyone gets those changes. And so these basic freedoms are outlined by the Free Software Foundation, and you can see more about that in the given website of fsf.org. So there are drawbacks of R. I won't go through all of them, and probably other people may have many more complaints. But there is some basic drawback, which are one that is essentially based on 40 years. This is based on 40 years technology, old technology. So the original S language developed in 1970s, but it was based off on a couple of principles. The basic idea have changed too much. Haven't changed too much. This is quite old, but yeah, it's still in the use and one of the best tests packages you can see. But it is old. Since then, and so one of the result of is that it has got little bit built-in support for 3D graphics, but things have improved now. Not on that front since the old days, and there is a lot of interesting tools now now are the part of packages for 3D graphics. Another backward of R, I hear about it a lot. The functionality is based on consumer demand and basically user contribution. So if one feels like implementing your favorite message, then that's your job to do. So you can't approach a corporation. There's no company that you can complain to. There's no helpline then that you can call to or demand a specific implementation or a specific feature. If the feature is not there, then you have to build it, or at least you can pay someone to build it. So this is another drawback, but you can hire a freelancer or somebody who can do your stuff. Another drawback, which is a little bit more technical, is that the objects you manipulate in R have to be stored in physical memory of the computer. So this is another drawback. If your computer has less memory, your object is bigger, then you cannot load it into your memory, and then therefore you can do something in R with that object. So there have been a lot of advancement to deal with this too, but it is because of your computer, your hardware side has improved, your computer contains tremendous amount of memory, and so some problems had been resolved just by improvement in technology. But nevertheless, as we enter the kind of big data era today, where you have larger and larger data sets, the model of loading objects into physical memory can be limitation. And finally, I'll just say that R is not ideal for all possible situations. So, you know, in a way, it is good thing that that they should not have high expectation. They have, in a way, it is like you have high expectations of R, but they have to understand the limitations also. So it doesn't do everything, but it's good enough for the data analysis what we do today in today's era. So let's talk about design of our system. So the basic R system is divided into two parts. What you can think of as two conceptual parts. There is base R that you can download from CRAN, which is comprehensive R archive network, and that is the kind of go to the place for all R things. Then there is kind of everything else. So the base system contains what is called the base package, which is kind of low level functional fundamental functions that you need to run in our system. And then there is other packages containing the base system, which includes, for example, util, stats, datasets, graphics, bunch of other packages that are kind of fundamental packages that are more or less everything everyone might use. Then there is a series of recommended packages. So boot for bootstrap, class for classification, cluster, code tools, foreign, and variety of other packages. There are the commonly used packages. They may not be critical packages, but they are commonly used by many people. So all these packages come with this. The base R system can be downloaded from CRAN. Now, but there is much more than this obviously on the CRAN. There are right now around 4,000 packages available on CRAN developed by users, programmer all around the world. These packages are contributed, they are not controlled by the R core, and they are uploaded to CRAN on every day on periodic basis. So one nice thing about CRAN is that you get lot of packages. You can download these packages up to certain level of quality. So there have to be, for example, there has to be documentation for all the functions that are in the packages, and there has to be uh, certain number of tests which has to pass. So CRAN has lot of different packages written by users, and the number is really increasing every day. So it's very exciting to see all the packages on CRAN and see new ones which is coming up every day. There are also packages associated with bioconductor project, which is packaged, which is project designed to implement our software for kind of genomic and kind of biological data analysis. So there are also other packages made that people make available on their personal website. There is really no reliable way to keep track of how many packages are available in this fashion. So there is really thousands of packages out there written by people and that you can discover and use to analyze data. So um, there is there are a couple of documents that you can find on the R website. As you are learning to use R, you then want to flip through some of these. One is an introduction to R, which is relatively long PDF document. Now that kind of goes through the basic of how to use R, how to use the language. There is writing R extension manual, which is really useful to read if you are thinking of developing R packages. Then there is the R import and export manual, which is useful for getting R data into R language and various different ways. The R installation and administration manual is most useful if you want to build R from the source code, and I'll talk about this in another video, but this is one of the useful stuff you should go through. Then you have R internal manual. It's a really technical document, how R is designed, how R is implemented at a very low level, and it's not really for the faint of heart. But if you are that kind of person who wants to go through the core part of it, it's very good document for you. So I'm just going to end over here with a couple of texts that are kind of standard for or classic text in this area. Of course, the book by John Chambers offer data analysis and programming the data. Both are published by Springer, and there are two books by Bill and Brian. One is called Modern Applied Statistics with S, and another one is called S Programming. Although they have they are talking about S in the title, but it is quite relevant for R programming as well. Then you have there's a book of Pin Horand, which is mixed effect of model in S and S plus. This is also quite useful. And finally, we have Paul, who designed R graphic system, which has been written, and it is he's the original author of our graphic system, and he has written a very good book about it. I think right now second edition is going on. It is published by Springer again. So this is quite a nice series of book that you may be interested in, and then there may be book written for you particularly in area of publication. So this is all about our history and the resources around R. In next video I'll start talking about details of R programming language and how to use, how to do, how it is useful to analyze data.